Hi, Kenzie. Let's check this one out. So, we know that the secant of theta is negative 19 and the tangent of theta is 0. All right, so the secant of theta, let's kind of think our way through this a little bit. Remember, the secant of theta, that's like saying 1 over the cosine, right, of theta. That's the inverse of the cosine. So, because this is over 1, if I were to flip this over, the cosine of theta, that's going to equal 1, negative 1 over 19. So we know that. Um, the reason why I'm flipping it into cosine is because that's actually the trig function that I remember. So remember, the cosine of any angle is x over r. So I know right away now, just from thinking this through, that x equals negative 1 and r equals 19. Now r is always positive. X, though, could be negative 1, it could be positive 1. I don't really know what's going on here. One of these could be the negative, but because r is always positive, I know that it has to be x. And if you didn't catch that, they're trying to tell us that the tangent of this has to be bigger than 0. It has to be a positive number. So remember, the tan of theta is y over x, right? Which means this whole thing has to be positive. So therefore, either both y and x are positive or both y and x are negative. That can be a thing too. So here, because r is always positive, I know that this x has to be negative. Therefore, I know that y, whatever that is, has to be a negative 2. I have no idea what that is, but I know it's got to be a negative number because this is specified right here. So with that being said, we need to find y. And probably the quickest way to do it, we could use trig identities. That's probably a little beyond right now. So let's just use the good old distance formula, where r equals the square root of x squared plus y squared. All right? Now what I can do is basically square both sides here. When I do that, I get rid of the square root on this mess. And now we can rearrange to get y by itself. I can just subtract x squared from both sides. So therefore, and if I just swap the sides here, y squared is going to equal r squared minus x squared. Now I know what r squared is. R is going to be 19 squared minus x being negative 1, quantity squared, and we can figure out what y squared is from there. So calculator time, 19 squared, I actually had to calculate that. I don't know this off the top of my head, but it comes out to 361. Now minus 1, negative 1 squared is just 1. So that's going to be 360. All right, now we could decimal that, but again, they want exact values here, so that's not really going to help us. So what we'll do, we'll say y equals the square root of 360, because again, I have to take the square root of both sides. And let's just reduce this, right? I'm going to rewrite this by factoring out my biggest perfect square, which is 36. 36 times 10 equals 360, and then I can take the square root of 36. So y is going to equal, now it's got to be a negative, we know that, but this is going to equal 6 root 10. Okay, I hope you see where that comes from. The square root of 36 is 6. The root 10 we just leave because it's an irrational, and remember it has to be a negative from this fact right here. So I hope that's all right. But now that we know x, y, and r, we have this thing cracked wide open. We can just write all of our trig functions. Any trig function we're asked, now you should be able to write it. We got her, right? So first one first, sine of theta. Oh, let me get a color. Sine theta. Sine theta, remember, is y over r, and we just write that in, right? That's going to be negative 6 root 10 over 19. And you can put the negative out here. It's probably more proper that we do that, right? But there it is. So that's our sine theta. Our cos theta, we already know that, but again, we could write it right out if you want. Cos theta is x over r. Remember, x is negative 1 over 19, or just negative 1 over 19, right? Tan theta, that's y over x. Let me just erase some of my mess here. You probably see where this is going anyway, right? So feel free to skip along if you do. Y is going to be negative 6 root 10 over x, which is negative 1. And that's basically, we don't write the fraction over 1, and the negatives will cancel, right? So that's just going to be 6 root 10. That's going to be our tangent. I'll erase this because I need some room. And we'll just do the inverses of all of these, right? Basically, that's kind of what we're going to do. Erase, erase, erase. So the secant was given to us. We actually know what that is already. They probably won't even ask you to blast that in. Let's do the cosecant. Okay, so the cosecant is 1 over the sine being y over r, so this is going to be r over y, right? R being 19, and y being 6 root 10. Now that's no good. We have to rationalize that. So what I'm going to do is I'm just going to multiply top and bottom by root 10 over root 10. Basically whatever a radical part is here, you're just going to multiply that by itself. Up top, this is going to be 19 times root 10. Now keep in mind these are two different species of numbers, right? This is an irrational number, decimal that goes forever. This is just a nice whole number. So this 19 actually interacts with this coefficient of 1, which we never write. So that's how I get the 19 root 10. Now down below, we're going to have root 10 times root 10, which is root 100. Square root of 100 is 10. 10 times 6 is 60. And it's always a good idea just to look and reduce this little fraction, but 19 is a prime number, so there it is. That's going to be our cosecant. And then the cotangent, same deal, we just flip. Oh, I need an eraser, not a highlighter. Our cotangent theta, we can just flip our tangent, right? But again, I'll just write it out. Cotangent theta. Now the tan is y over x. The cotangent is x over y. So that's going to be negative 1 over negative 6 root 10. Again, we'll rationalize that. Root 10 over root 10. The negatives are gone. Up top now, I have basically just square root of 10, or 1 root 10, but we don't write the 1. Down below again, this is going to be root 100, which simplifies to 10. 10 times 6 is 60. All right, so there you go, buddy. That's kind of the big trick. We want to get x, y, and r. Use the distance formula if you have to. Reason your way through it, because when they give you one trig function, they actually give you two of those, right? They give you x and r or y and r, so that's really useful. And then again, just keep in mind where we are in the coordinate system. And that's going to help you just figure out whether things have to be negative or positive, and then go from there. I hope that helps. Let me know if it doesn't. Bye.